Good morning. My name is Sofia Kukec, and I'm about to enter the 9th grade in the United States. I currently, Wolfpack is where I work with currently, and it's a CubeSat development team located in South Florida. The Monte Carlo method is a risk assessment method created by Stanislaw Ulam and John von Neumann during World War II, and was created to improve risk management within the project they were working on. Nowadays, it's primarily used in finance and portfolio management, but it can be applied to industries such as aerospace. Aerospace is a very risk-prone industry with many different factors and outcomes that can potentially make or break a mission, meaning Monte Carlo is a very effective method to help mitigate risk in aerospace. For example, Astrobotic Technology attempted a moon landing mission this year. However, the mission was not completed due to a fuel leak. The Monte Carlo method, or a similar risk assessment simulation, could have been used to mitigate this risk more effectively. A successful example of Monte Carlo in aerospace is NASA's Europa Clipper mission, which will explore Europa, which is one of Jupiter's icy moons, potential for life. The Monte Carlo method was used to test how total ionizing dose from Jovian radiation could potentially impact the hardware. This risk was then mitigated by placing the hardware into a radiation-proof box that would slow the effects of TID. Another successful example is the WISAT-1, which was launched by the Wolfpack CubeSat Development Team as their debut mission in 2018. The Monte Carlo method was used to test the probability of the Wolfpack's CubeSat colliding with an accompanying mission, due to CubeSats commonly being launched as secondary payloads. I built upon these ideas with my own CubeSat deployment simulation, involving 3 1U CubeSats lined up in a deployer with the helical spring as the deployment method. The speeds differ due to the CubeSats traveling different distances and being pushed with different force. As the CubeSats are ejected, the spring will push less mass. The spring constant chosen was 3 newtons per meter. With the displacements and spring constant in mind, Hooke's law was used to find the force, which was in turn used to find acceleration, as the mass was already known. The Monte Carlo method was applied to this experiment using the launch angles at which the CubeSats are deployed. The CubeSats do not fit perfectly inside the deployer and therefore have room to move around. Because of this, they are deployed at slight angles, ranging from -1 to 1 degrees in the simulation. These angles are randomized 10,000 times, and an average for each CubeSat is found. These averages are then used to find the final velocity. This final velocity then is used to find displacement over time using antiderivatives, which is the graph in the bottom right. The graph shows that the CubeSats will most likely not collide, as they are deployed at different times, have different enough launch angles, and the results table shows that their velocities are very similar, meaning they will most likely not collide. In conclusion, the Monte Carlo method can be used to better mitigate risk in the aerospace industry. Poor risk management has proven to be an issue for aerospace in the past, and the Monte Carlo method can be an effective solution due to its high fidelity. Thank you.